Hello everyone, I am your guy Ponderado here again to help you develop your game step by step. And today we're going to learn how can we implement a 2D top-down character controller that can only move from up to down and left to right. And why is that? Why only 4 directions? Well, the reason is because if you are looking out there for assets for your game, especially for the character controllers, sprites, related to your character, you end up noticing that a lot of them, they only provide sprites for these 4 directions. So if you try to move diagonally with only 4 sprites, it will look a little bit strange. Sometimes it is what you want, but sometimes it is not what you want. And in our case, we are going to move only in these 4 directions. So I'll help you. If you follow step by step, you end up in this video with your character working. It's not hard, it's actually really simple, and just follow me and let's do it! Alright guys, so let's break down all the work that we're going to do right here in this video. Splitting in 5 steps, the first thing that we are going to do is to get our sprite. And don't worry, I'll be talking with you all the details in each step, but as an overview, we need to do first is to get the sprite, find our sprite. The second thing is to convert these sprites or those images into animations, because what we are going to see in our character are animations playing. The third step, and there we'll start to code, is to read the player input. Fourth step, we will move our character based in the input that we have get from the player input. And finally, we will update the animations based in the movement. And so this is it. This is what we are going to do. Let's start talking about the first step, that is getting our sprites. Excellent. Now it's time for us to resolve how can we get some sprites. Well, in the game, we have the image that will represent our player, our character, and usually any image in games that are representing the player or the character or even objects, trees, anything, well, we call them sprites, and this is what we are looking for right here. So if you are already an artist, you can create your own sprites for our character. But if you're like me, don't know much about art and pixel art and everything, well, let's find something useful for us. Okay, one good source that I found is this website called itch.io. You can find a lot of cool things right here. Of course, Asset Store from Unity is also a good source, but if we're talking about pixel art specifically, I believe that itch.io is the best source that we can find. And well, we just searched. I am searching here for something like characters and top down, and I have filtered for free, and we have a lot of options. Look at this, awesome. But for my case, I am grabbing this package right here. And we have this Adventure 2D top-down from Xeni. Thank you, Xeni, for helping us to make this happen. There is more work from him if you are interested. This package don't include all the animations that you see here. For example, the dash animation, I believe that it's not included here. You can pay for them. The package, if you pay $3, you can get the complete package, but for our case, we just want the idle and run animations, and this is what we are going to use. For example, I have another package. I will bring it in the project, so we have a small discussion. I will be using this package, but this guy will teach us something, because every case is a case. Every sprite, every download, you can get different files, and I found out that they are using 2 different organization styles, and it will affect how we will set up our project. Okay, but let's get back to Unity. So I am opening Unity right here. I am creating a new scene. Let's create an empty scene. We need a camera so we can see what's happening. I will change it to orthographic, and I will change the background type to solid color. Let's grab a, don't know, maybe a gray color. All right, this is fine. And what I'm going to do is to download. I click in this download. I have already done it, and I have the file right here. This is the files that it provided. Another important thing is to be aware that we are not violating any legal right. So always take a look in the license file. In this case, you can use this asset in any game, personal or commercial. And I don't want to resell or redistribute as a game asset, so we're good to go. And credit is not required, but appreciated. Again, thank you, Axeni, and Snowbling, thank you as well. Okay, we have the files. We need to import it into our project, so I will create a folder just for organization, and I will call it Sprites. Enter this folder, and let's grab our image. So, Sprites. We have different sets right here. You grab the idle down, for example, and I will put all of them in the project and run as well. Grab all of them and drag into our project. In this case, right here, we have also the prototype. I mean, these little guy right here. Just for an example, I will create a folder prototype, just in case that you choose this asset, for example. Let's do this way. I will grab the PNG file, and notice that we have only one big file, and I will explain to you in the next step how can we split this into different animations. But so you can see, just so you can see that we have different ways of organizing. Every artist have its own styles. This one likes to split different animations in different sprite sets, sprite sheets, and this guy just put all in a single file. Okay, now we have our sprites. We are ready to start the next step, and the next step is how can we convert these files into animations. Let's see. Alright, now how can we convert those images into animations? Well, this is the next step that we're going to solve right now. So, in this simple case, in this first case right here, the author decided that he'd split down all the different animations in different files. Well, let's try to grab this and put in the scene. It won't work. Why? First thing is that we have set up some stuff right here so Unity can understand this is a sprite. Let's grab all of them, and we can change all of them at once, changing from default texture. So let me grab it again, all of them. Default to 2D and UI, sprite, see, sprite right here. This is our option. Next step, save. Again, I'm not sure if selecting all of them. Yes. We need to change the generate physics shape. We won't be doing this in this video. We want also to change this point no filter to be linear to point no filter. But before we do this, let me apply. Let's go to the scene. Let me grab a single image right here. It's not working yet. Why is that? I don't know. I actually don't know. Oh, yes, I know. This is because we need to install this 2D sprite package, okay? You need to have a specific package for this. If we go into the window package manager, we have the Unity, and if we search for sprite, I am very sure, actually I am sure that we get some kind of sprite asset, but sometimes it takes time to load it. Let's wait for Unity. Okay, here it is. So we have 2D sprite right here. This is the package that we need. Let's just click in install and wait for it to install. It won't take long, just wait a little bit and we're good to go. Perfect, now we have the sprite package ready to work. Let's try something. I will try. Well, not working yet. We need more stuff to do right here. Let's grab the idle down, for example, file. And what if we click in Open Sprite Editor and we click in Slice and Grid by Cell Count. What we are trying to do is, an animation is a set, a group of sprites that are being rendered or presented in a sequence. So the first frame of our animation is this one, the second, the third, the fourth, the fifth, and so it goes. And we need to break down in single images what we are going to show into the scene, because we have 8 images in a single file and we want to represent only one image that it's changing from step to step. Okay, so let's click in this grid by cell count in my case, and I will choose the 8 because I know there is 8 sprites that I can use right here, and I will click in slice. An important thing to say is I don't want the images to have different sizes. For example, I like the pivot to be on the same point, because if we change, for example, imagine that this image is sliced this way and the other one is this way. The pivot will change because the pivot is right here and the pivot is right here. So when I split the image, the pivot, the center of my image will be this point right here. And when I swap from this image to this other, well, it will have a strange behavior because there will be a jump in the image. It's not centered the same way. So we need to keep them all centered in the same position. All right, important thing. So apply. Another important thing that I want you to see is, notice how the image is blurry. It's kind of blurry, right? Well, we can change it. The filter mode is responsible to solve it. So let's use the point or no filter and apply. And now we get the crispy pixelated image that we want. Okay, this is why we're using the point no filter. Do it for all of them. Let's change it to point no filter, and now I know it's boring, but you have to do for each single of these guys. You have to do the same thing that you did. Open the sprite editor, break down into single or multi-slice it, just slice the image the way it is supposed to be, slice it and apply, and do it for all the others. Now, if your project, for example, if in your project you're using a different kind of set, for example this one, we have only a single image, what can we do right here? Well, first, same thing, we just change from default to sprite. We also want to use the point no filter, and we can open this sprite, disable sprite physics, generate physics shape, and open the sprite editor. Okay, now what we can do is tweak some stuff to make it work. So I have kind of 4 columns. Let's try 4, and let's break down with 1, 2, 3, 4. Let's play some numbers and see what happens. 12, perfect. Very good, very good, very good. Apply. Now what happened here is this single file inside Unity is split in several minor PNG files. Okay, and it's called sprites, I guess. So all of these, all of them are sprites. Each one of them is a single sprite. And notice that if I press the button, we can see that, well, it's kind of one animation working right here. Exactly, we have different animations from the same file. And the same way, if we go back here in the idle, we can notice the same behavior. When we swap the sprites at a certain speed, it will be an animation, and this is what we're going to do. So how can we bring this to Unity? If we just click it, drag and drop, well, we have the sprite right here. Okay, we have the sprite, but it's not an animation. What we need is an animation. So I will delete it. I will click selecting multiple sprites, drag here and drop. And now Unity will solve it for us. It will understand that, well, this guy is trying to get an animation from these sprites. Let me help him. I am going to go into the top-down character, and I will create a folder called animations. Okay, so we have sprites folder, and now we have the animations. And we can name it the way we want. I am going to name it idle down. I suggest you to name the same way. Okay, idle down. You can name the way you want. If you want minor case only, idle down. But be aware that how you name, it's important, because it will affect how we will code, how we'll name our animations later via code. Okay, so save or through code. And one strange thing that I'm noticing right here is that I don't see anything in my camera. This is because my camera is at the same point of my sprite. So what it's being rendered right here, it's from this point beyond, but this point is exactly, it's like it's inside our camera. So let's grab our camera a bit back. Camera, we can put it -10, and notice one thing. When I move the camera, it doesn't matter how far it is, it won't affect the size of the sprite. This is because we are using something called the orthograph representation. If you're using perspective, now the size is affected. But when we're talking about 2D games, usually the good idea is to go for an orthographic camera. Okay, now our sprite is too tiny. We need to make it bigger. To make it bigger, we can change some configuration right here. See, you know this pixels per unit? I will create in my scene a cube, and what this is telling me, this pixels per unit is telling me, is that in 1 unit of Unity, so this cube have 1 unit on each side. I believe it's metric unit, but each meter, each 1 unit will have 100 pixels. But take a look at our sprite. It's too tiny, we need to make it bigger. So if we change this value, for example, in 32, it means that in this space, we'll have only 32 pixels and not 100 pixels anymore. So what we should expect is that the image get bigger. Okay, so apply, and here it is. Do it for every single of the animations of the project. All right, change the pixels per unit for the correct size. Sometimes the asset will say to you how many pixels it is, and sometimes you have to tweak it and find it on your own way. Okay, another thing is that we have the size. So if we change the camera distance, won't change the size. How can we get closer to this player, this character? Well, we can change the size of the camera, And this is how we do zoom in and zoom out in our game. All right, so I will put for a size of 2 in this camera. And let's take a look in the prototype. Back in the prototype, in the other case, we have this single image with all the sprites from different animations. We need to manually break down into different animations, and how can we do it? It's really simple. We need to find, and it's kind of boring, but we need to find the sprites related to the animation. For example, I noticed that these 2 sprites represent the idle animation, so I grab both, drag it into the scene, and I call it, for example, XYZ because I'm going to delete it. But here it is, and notice it is super small again because the pixels per unit is 100 and our image, it's like super tiny, 32 pixels. So if I want this entire image, considering even the white spaces to be this size of this cube, so this size will match this size. If I change it to 32, now we got it. Okay, and well, we need to do it manually. I have the animation XYZ, and another adjustment that you may need to do is to fix the, let me find, what is the XYZ? Where did I put the XYZ animation? Ah, here it is. Another important thing is that we have the XYZ, the animation right here, and if we go for play mode, you may need to adjust the speed. This one is fine, but this one is too fast. What can we do right here? Well, what we can do is to open this animation. So double click right here and the animation will open. If it's not open, Unity will bring you this animation screen, but I believe that you can find here animation, okay? And we can change it. How can we change the animation? We select the object, for example, this animation XYZ. I want to change the time. I drag all the nodes right here and I can scale them. And we can test it. See? You can also modify if you want to, for example, create another node. I will grab this node, I can copy using Ctrl+C, and I can paste it right here. I can also modify other stuff. For example, I can use this flip right here. I can grab this size, for example, and change. But this is not a video about animation, just so you can understand that we can tweak things in the animator, okay? But this is it. I believe that this is all you have to know to understand how we can convert our sprites into animations. And next step, we start to code. Alright guys, I have cleared my scene, I have added some animations, we have the sprites, we have the animations. Well, let's play to see one of the animations working. So when we open the image and drag the animation, the sprites creating the animation, this is supposed to happen. Okay, so we can check the sanity check. Alright, and I am going to delete all of these animator controllers right here, except by one. And I will rename it to the top down controller. Now it's time for us to read some inputs. So the player is going to press the keyboard, some keys, or he's going to use the controller, joysticks, and we need to be able to read this information. And how are we going to do it? First, I want to grab this animation right here that I have dropped. So when I drag this into the scene it created for me. I will keep it one of them. I will create an empty parent. I will call it the player. You can name it the way you want. And right in the parent game object, the player game object, I am going to add something called player input right here. Player input. It's a component provided by Unity using the new or not so new anymore input system. So usually back in the days we used to type input.getKey down and other comments directly in code and things used to work. But in newer versions of Unity, this is not going to work anymore, and we are going to use the new input system nowadays. Okay, we have this player input. And what is this thing? This is a component that can automatically change and read different kind of input systems. So for example, we have the keyboard, we have the gamepad, we have touch. You can even be using VR. And the VR, it's using this XR component right here. And we have this thing called the actions. If we open this object, click twice, we have these things called maps. So imagine that maps are different sets of inputs that we can use. For example, when we are controlling the player, we can, what are the actions that the user can do, the player can do? They can move, they can look, they can attack. All different actions are binded to this player map. And the user interface actions, for example, going up and down and pressing enter, are all binded to this UI action map. And if we expand some actions here, we will notice that we have different inputs for this action. So we have the action that we call move, for example, but how can we trigger this action? Well, if you're using gamepad, the left stick is going to trigger it. If you're using keyboard, the WASD key is going to trigger it, and in joystick, the stick is going to trigger the same. All of them are triggering the same action, that is move. It's a value vector too, x and y axis, that will be filled when we execute any of these input actions. Okay, so a basic and super fast overview of what is going in these input actions. These input actions are provided by the Unity when we import the package. So I'm not going to create a new one, but you can create a new one just by clicking right click, create and input actions. But first, let's make sure that in your package manager, in window package manager, we have the input system. Actually in project should already be here. Okay, it's here. So this is why we have these input actions and all the other stuff. If we don't have it, it won't work. Add this package first, and then you will find this player input component, add it to the player. And now what I want to do is to set the map to player, correct? We are not interacting with the UI, we're interacting with the player. And take a look that we have different messages. The unit component provides us different ways of reading all these values. So all of these values, these actions, for example this vector 2, we can read all of these different values in different ways, and Unity is providing us the send message method, the broadcast method, the invoke, Unity events and C# events. Let's stick with the send messages, the super simple send messages. So every action that we have in the map will become a known method. So when we inside our code, when we fill this onJump method, it will know that we are trying to read the onJump or the jump action here. Okay, so let's do it. We have the input action. Let's create a new script to handle our player. I will create a new folder and I will call it eScripts, and I will create a new C# script, in my case mono behavior script, or we can go here to create the same thing, and we're going to name it the player controller 2D top down 4-axis. Okay, it's a big name, but no problem, you can name it the way you want. If you want just to name it player controller 2D or player controller or even player, it's fine, no problem. It's just the way I wanted to name it. Now I am going to drag the script into the object of the player right here. And I like to put my scripts on top. And now it's time to open this script. And the magic is really simple. I am going to delete all the content inside here. And now we need a new method to read the input that we are getting. So remember, the method that we want to read in our case is the onMove. Okay, onMove. Why onMove? Well, because onMove is, let me open here, onMove is this vector2 action that is triggered by AST. So this is why we are reading move, because this is what we want, okay? Going back to the code, now what we want to do is the method onMove, onMove, exactly. I'm going to type in my code void onMove, and I am going to add the input value inside it, and now what I can do is debug.log the value inside this input. So we can debug log this value this way. We can do something like value.get, and we get vector2, and let's check if this is working. I hope it is, because I already included the input system automatically detected. So when I press the AST key, I am hoping to get a debug block. Let's test it. And wait, I open the console, play, press some buttons, and it's working. Notice that we have a vector2 being filled. When I press the left key, the x-axis is -1. When I press the right key, D, it's getting filled with the value 1. I'm not sure if it's working for arrow keys. Yes, it is. Nice. And we have a problem, because when we press, actually I think it's already normalized. Very good. I didn't know it was normalized. Let me check quickly. Well, seems to be normalized. Yes, it's normalized, but if it wasn't normalized, we would need to add a code when we breathe. We would need to add something like normalize it, and we would be fine to go. But we need to store this value, so let's create a vector2, call it the input direction, and when we execute the onMove, we are going to fill this input direction exactly with the value vector2 normalizing. Just to make sure, I am making sure that we are going to get it normalized, because we may change the input later. So just to make sure, I normalize it again, and we're good to go. Now we're reading the AST keys, or the arrow keys, or even the joystick should be working right now. Next step, we are going to move. Actually move. We are reading input. Next step, we're going to move. Well, now we need to find a way to move this little guy right here, our player. Okay, and in our game, we are supposed to move only in the x-axis and the y-axis. And how can we do it? Well, here we have the transform component, and we can, of course, directly change the x-axis, the x value of this transform, or the y value. We can do this via script. Problem is, usually in games we have some kind of collisions, so we can have some obstacles, doors and walls, and when we move something over another something, for example, if I move this player and it overlaps, for example, a wall or a box, well, when it's overlapping, we should not allow it to happen because it is a collision. The player should never enter the wall, and, well, we have to solve this collision when we have an overlapping situation. And we don't want to program physics collision because this is an entire idea. It's super complex. Actually, it's not that super complex, but it takes time, and we're not worried about physics at all. We just want things to work, and we can use what is already done. So let's use what it's done for us. What we can do is to use something called the rigid body component. So we have the rigid body and rigid body 2D. By adding this, we are simply delegating the responsibility to handle physics and collisions for Unity. So the entire physics engine is programmed, and we are using it when we add this rigid body. So notice that we have this parameter called the gravity scale, and when we play our game, our character will start to fall down because, well, we have 2D games that can use gravity, for example, Angry Birds. But in our case, this is not true. We don't want gravity, so let's make the scale as 0. And, well, this is good, but this is not enough because even though we have the movement, we can move our object, we have to describe in our world what is this physical space that this little guy is occupying. And to describe to the game what is the physical space, so a collision is when we have an overlap of objects, and this overlap is of some collider. We call it the collider, the thing that describes the space that the shape of this guy in the world is the collider. The physical shape of this guy in the world is the collider, and we have the 2D colliders for this case. And in our case, we can use, for example, the capsule collider and the circle collider. You may think that we should use the capsule collider right here. So let me go back here. Because usually when we are handling the 3D games, we usually use the capsule collider. So let me adjust something like this, and I will bring it down a little bit. Okay, imagine that this is the physical space that our character is occupying. What is the problem with this approach? Why will this won't work? I have to draw something right here, so let me show you something. And, well, this is our player. So here is our happy friend player. Okay, and this is our player collision. Now imagine that we have a wall. So we have a wall. Okay. And this wall, what is the collision? The collider of the wall? Well, this is the collider of the wall. Anything that should be an obstacle, it's have a collider. Okay, so we have two colliders. And what is collision in game physics? It's overlapping of shapes. So if we notice here, the colliders of our player, this capsule collider, is overlapping with this wall, and it means collision, so it shouldn't be allowed. And what would happen is that we should not, it won't work. It would never happen. What would actually happen is the real situation with this collider is that we would end up with a case something like this. So we have the maximum position that player can go is this position. with this setup using colliders. We cannot go any closer to this wall, and all of this space is not reachable because the collision already happened. And what can we do to solve it? It's simply, well, use a smaller collider. So let's consider the collision only in the foot of the player. So this is the collision and this is the collision. So now we can get closer to the wall without colliding it in a way that feels closer to the wall. So this is why I suggest you to not use capsule collider, or at least be careful because this will happen. So be smart about it, and I will change it to circle collider 2D. I'll make it smaller, bring it down, something like this. I think this is fine. Okay. Very good. Now we have the physics engine ready to move for us, and we have the collision, the shape collision being detected. Now what we need to do is to add some code. So we need to, via script, tell and ask for this rigid body to move. Let's go to it. So in our player 2D top-down controller, open this. What we're going to do now is come here right now. Okay, I think that I have some code, unsaved code. So let me go back to the state that we were before. I was playing something right here. I was trying something. But what you have in your project is something like this. You don't have the rigid body, you just have this, okay? This is what we have. Overwrite, I don't care, overwrite, okay. This is what we have, perfect. Now, how can we move? First thing, we need to get our... First thing, I think the best way is to get the rigid body. So let's grab this rigid body. So, serialize the field. And we can add a rigid body. And then don't forget the 2D, so it won't work. And we call it the rigid body. So Unity, give me your physics system so I can use it to move my character. Okay, this is what we are trying to get right here. Another tip is that you can use something like require component and type of an rigid body 2D. So instead of manually assigning it via inspector, we can force every time that we drag this script into the player, into the object, it will automatically add this rigid body. And we can do something like awake. So we have the awake method and set the rigid body as the get component rigid body 2D. All right. We can do without this serialized field, but if you want, you can use you assign it in inspector. It's just the way that you prefer. Okay. I will delete this and this. Let's do all by code. Now we have our rigid body. We want to move. What if we try to move it already without any handling? Let's do something like this. We have the method called fixed update in Unity. Fixed update. Wrong case. Sorry. So we have the fixed update right here. This is a method from Unity, and we can use our rigid body. So unit physics, please set the linear velocity to what? To our input direction directly. What will happen right here? Input direction. Let's see what happened. Let's see what will happen right here. Wait and let's go. ta-da, we have movement, but we have diagonals movement, and this is not what we want. We want only to move left, right, up and down. So we have to restrict the movement to this case. Okay. One special thing to talk here is we are using this fixed update. What's the difference between the update and the fixed update? Well, update, it's called every second, every frame. So every time we render, we display an image in the screen. So imagine that a game is a sequence of images being presented in the screen. The frames per second is exactly this. We have frames that are present each second, and every time that we display a frame in the screen, this method will be called. Okay, this is the update method, but we cannot guarantee that the frames are always at 60, always are 30. Sometimes the frame can drop, the frame can go up, and this is the difference between the update and the fixed update. The fixed update have a fixed time, so no matter what, every 0.02 seconds, I don't know, I don't remember where it's located, this information, but every specific time and always the same time gap will happen, it will be called. No matter if it's rendering a frame or not, let's suppose it's 0.02 seconds, it will be called, no matter if it's rendering or not, and this is called every frame. Every new frame, we call this. This is the difference, and usually physics, when we are talking about rigid body, we usually, it's a good idea to use the fixed update, okay? So just for an idea, so only for a simple explanation. Now, what we need to do, going back to the development, we need to limit the input to only move up, down, and left, right. So instead of changing the input direction, what we can do, and I think it's a better idea, is to create a new vector 2. We can call it the move direction, okay? And in the update, so every frame now, usually only physics we handle in fixed update, but now we are handling not physics, it's input. So let's use the update. In update, we set the move direction as vector 3.0, 2.0, okay? So by default, we are not moving, our character should be static and standing in its own place. And now we check the input. So if the input direction and .y, for example, is greater than 0, it means up and down. Remember, x is horizontal and y is vertical. So y vertical, up and down. If y is greater than 0, f, we are changing the move direction to a vector 2 dot up. All right, we are moving up. Now, if you're not moving up, if our input direction .y is less than 0, now our move direction is equals to a vector 2 dot down. This is where we want to go. Else, I'm sorry, if. Now, if we want left and right, so this is up and down, okay? And now we are handling left and right movement. Else, if input direction dot x is greater than 0, our move direction is equal to vector 2 dot right. And finally, if the input direction, actually this is an else if, input direction dot x is lower than 0, finally our move direction is equals to vector 2 dot left. Now, instead of directly using the input, we can use this move direction, and let's see what happened. I'll go back to the game and we will play. And let's wait. As always, we have to wait. So, okay, and I cannot move diagonally. I can only move up, down, left, and right. Perfect, this is what we want. Well, the final step here is to update our animation. Okay, so we are moving correctly, we have the animation, but we are not playing the correct animation. So we want to change the animations based on our movement, and this is the next step. Let's finish this. So now we have to animate this character in different directions based in the movement. So remember that we have this component called the animator, and notice that the animator is inside this child component and not this parent component for this case. Let's open this animator, and remember, animator is the player of animations. So different animations that we have here is supposed to be here. If you have any animation connected to this entry, you can delete it, and let's configure it from scratch. So all the animations that our player can play all of them are right here in our folder animations. So the standard, the default animation that we want to play is animation directed down, exactly as we are seeing here. So this is the idle down animation. So I grab this animation, and drop in the animator. So the entry point of our player of animator is the idle down, and let's bring all the other animations here. So I'll get all of them, drag and drop, and let's organize it. We have the idle down, idle up, I need the idle left and idle right. We need the run down, run up, run left, and run right. Here it is, all the animations that we can play in our player. We are not making any transition, okay? For usually 2D games, especially, in general 2D games, I believe this is a better way to handle it. We can use transitions, but let's control all the animations by code. I think this is better for this kind of game, okay? So I'm saving it, and now we have to find a way to play all of these different animations right here. Back in the scene, grab our player, let's open it, and what we need now is a way to use the animator component. So what we will do is grab the animator and name it animator. Okay. We need to fill this variable, and it's inside the child of this object. So we have the player, but the animator is here in the child. So how can we grab this component? We can use the serialized field, but I will choose to grab it via code. So underscore animator equals get component in children and animator. Okay, get component in children. Now we have the reference for the animator. Next step is to handle our animation. So inside the update, one thing that I will start to do right here is to give name to the last direction that we... Actually, let's do it later. Let's first just play the animation and see what happens, okay? Let's break things and fix things. What is our goal here is to play the animation by name. So our animator component right here, we can play all of these animations if we have the name. So we need to find a way to grab this name here and send the command animator.play and this animation. If we want to play this animation, we just write animator.play and this name here, and it will play. So we have to find a way to build the string for the animation that we want. And what we're going to do is, let's call it the string as the let's call it the prefix animation. animation prefix. Okay, and I think that we can put it here. We don't need to create every time. And what we can do is to detect the movement. So if the movement is 0, our prefix is idle. What I'm calling prefix right here is the first part of the name. So we have two possibilities: idle, this column here is idle, and all animations here are the run. So the second row, the second column. Okay, so if the move direction is 0, it means that we are not moving. We will set the animation prefix. What? Okay, I'm sorry. Rename it underscore. Back here, animation prefix will be idle underscore. Else, if we are not static, if we're moving, the animation prefix will be, guess what? Run, because all animations running starts with run underscore. So we got the first name of our animation. The second step is to get the direction of our animation. And how can we get the direction? We can add it here. So let's add. Oops, delete, oops, delete, paste, delete, and I'll create a new string called the string animation postfix, and it starts as nothing. And well, animation postfix will be the direction. So we have the up, down, left, and right. In this case, it's up. And let's do this again. Delete, paste, copy, paste, and down. So this is the down postfix. Now we have the okay, paste, that, and this is the right, and finally we have the here we have the left. So the last position is set here, and now we can simply use the animator.play. And what is the name? The name is animation prefix plus animation postfix. So it can be, for example, idle, run, or idle up, or idle down, or left, or right. It can be run, right, left, up, and down. This is what we are trying to build in this string right here. Okay, animation postfix, and let's play and see what happens. I grab the animator. One important thing here is to set the animation. So we have the animations, and we need to check that loop time is enabled. Okay. Okay. Let's go player. Now we have our code, and let's just execute it. But let me bring this to the side so we can see it working. Here it is. Very cool. Notice that how this is automatically changing the animations. We don't need transitions. We just set the values, and it works really well with state machines. And that's it. This is how we can do it. But a final thing that we can do is to set the speed. So we can change the speed. I think it's too slow. And now Let's add a serialized field, float, and call this move speed, for example. And by standard, its value is 1. And in the fixed update, let's multiply our direction by move speed. And save. And we can change the player speed now. Let's see. So 1 is the value. Let's change it to 2. It's faster. Let's change it to 3. Nice. This is it. Now we have a 4-direction top-down character controller that it's prepared to be used in any kind of controller. So if you use a joystick, a D-pad, or a simple video game controller or keyboard, all of them will work correctly. Beautiful. Well, now we have achieved our mission, and I hope that you liked it. If you like, of course, clicking the like button. If you want to see more content, please subscribe to this channel. And that's it. I hope to help you more. We have a lot of content to share. And thank you. Goodbye.